Today's lesson is perhaps the most difficult lesson of all this school year for you mathematically, and we're going to try to take it as slow as we can. It's a lot of logical and deductive reasoning or thinking. Much like when you watch one of those shows on TV that maybe a lawyer show or a investigative show, a cop show, when they're solving a crime or solving a case of some kind, they always use what's called deductive reasoning, and that is basically what we're going to use to prove triangles congruent. We're going to have a statement, and we're going to have a reason to back it up. So anytime we say something or write something, we have to have a reason for doing it. We can't just say it is because we think it is. So we're going to start off first with some properties just to review some of those basic properties that we had earlier this school year in our previous lessons. I'm going to take number 1 first. Now recall that there are 3 components to this. If segment RU is congruent to segment WX and WX is congruent to segment YZ, then segment RU is congruent to segment YZ. Does anybody remember what property that is? Right, it is the transitive property of congruence. And I use symbols. I don't write words when it's commonly known abbreviations. That's what congruence means. So that's the transitive property. Does anybody remember number 2? Angle A is congruent to angle A. You are equal to yourself. That is the reflexive property of congruence. And then finally, number 3, if angle B is congruent to angle C, then angle C is congruent to angle B. So when you have a line of this, then it's same on the left and the right, or above and below, so on. That would be that other property that you're thinking of. That is the symmetric property of congruence. And really, when I say congruence, this should be congruent segments, congruent angles, if we want to get technical, which we don't need to. Okay, now we're going to start with writing a proof. And what is this proof thing? Okay, we have to have a picture, first of all, to start with. And within this picture, we're going to put tick marks and angles and so on to try to prove from the given or from the picture that we can get steps into a way to use or a way to prove what it is we're trying to prove. So we have what we call statements and reasons. This is called a T-proof because it looks like a T. Okay, the first thing you always write down are the given. That is always the first thing. And I usually write it in one statement. You'll see other teachers that do it in every given statement. Is it whatever? If there's 3 things given, you write 3 statements. I do not. I just do it all in one step. Okay, so we know those are given. Well, what is given? Well, we know that BC and AD are the same. That's given. They're congruent. We know that BC and AD are parallel. Okay, now from those 2 facts, the question is, can we prove that these 2 triangles right here are congruent? Now we got to take a step back and ask ourselves, what are the ways to prove triangles congruent? There are 6, if you recall. Hypotenuse leg, side, 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 angle, and angle, angle, side. 5, sorry. Did I miss one? Yeah, that's it, isn't it? 5 of them, not 6. So there are 5 ways to prove triangles congruent. So of these 5, is one of them appropriate for this problem? Well, I don't know. And neither do you. You may think you know. Some of you will just say, oh, side, 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 because they look like it. Or side, angle, side. That's our initial, that's what we want to do. That's the easy way, the shortcut. However, that doesn't prove anything. So when you write a proof, every statement you make has to be defended with by a reason. It has to be true because of a reason you know is true. So if we look at the picture, what do we know is true for sure that isn't already given? Well, first of all, let's look at the triangles. Is this going to be a reflection? A reflection? Or is it going to be cut them apart and rotate them? I'm going to get technical here. We would cut this, wouldn't we? And then we would rotate it to get D with B and this angle to here and this angle to here, right? So that's how so what would this segment, see they share a segment, don't they? They share AC. So technically, we should write that AC is congruent to CA. Technically. Now we could write just, I would accept AC congruent to AC, and I'm sure Mr. Hessong will as well. But to be technical, that's what would be congruent. So because of that, that would be what property? Well, let's go back and review. Hey, that looks familiar, doesn't it? I believe that would be the symmetric property. Of congruence. And we're just going to write symmetric. That's good enough. So we have 2 sides now. That gets us to either side, 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 or side, angle, side. It's got to be one of those 2. So looking at this, we cannot prove those 2 sides. We just don't have any way to do it. So the only thing that it might be is side, angle, side. And let's see here, I'm going to clean this up so we can see it a little better. So which angles could we try to prove congruent? These 2? Oh, no, because they look like it. So we can't prove those 2. Well, I got parallel lines, don't I? We got parallel lines. And here's your transversal. So this angle and this angle are formed by those 2 parallel lines and this transversal. Hey, what kind of angles are those? Right. Those are alternate interior angles. And we know that alternate interior angles are congruent when lines are parallel. So therefore, angle BCA would be congruent to angle DAC. Now, do we have enough to prove those triangles are congruent? And the answer is yes. Side, angle, side, right? So now we just write the congruent statement. And that comes from what we're supposed to prove up here. So your given statement is always your first statement, and your prove is always your last statement. The reason is going to be one of these if we're trying to prove triangles congruent. Now I know that's a lot to take in one spot. Well, let's look at this next one then. So we're going to start with a T chart here, or T, statements and reasons. I apologize for my writing. It's terrible, I know that. I'm going to write the given down. Hey, I'm always going to get 2 points, right? Because I just write the given down. That's a semicolon. Km congruent to Nm. Okay? Now we're supposed to prove that these 2 triangles are congruent. Now I bet you can look at this and know right away they share Lm. So can we just simply flip it, or do we have to cut it and rotate? Right. You can flip it, right? So LM, I still got to make this statement. LM is congruent to LM because of it's congruent to itself, reflexive property, right? Ooh, I think I messed up back here, didn't I? This should be reflexive, shouldn't it? So this is a mistake. See? Even the teachers make a mistake. This should be the reflexive property. Even though we didn't name them the same way, it's still the reflexive property. So that should be the reflexive property as well. Now I believe then we can cut right to the chase right now. We can say this, they're congruent by side, side, side. Now this is one we like, huh? That's easy, 3 steps. This took a little more work, 4 steps. All right, oh, this looks ugly. Write a proof, okay. Now we're starting to get the hang of things. We write our statement, our reasons. We always start with the what, the given. Now this is why it's so imperative that we learn what all these symbols mean. You thought you were just going to get away with learning them and saying I'm done with it and moving on to the next chapter. It doesn't work that way. We have to know that this symbol means parallel. We have to know that this is congruent. We have to know that these are segments in order to understand what this is saying. So if I read this out loud, it says segment AD is parallel to segment EC. And that's what we got here with the red arrows. Segment BD is congruent to segment BC. All right? Now, you have to be very careful. These are not congruent. That is not what those say. Those do not say congruent. They say parallel. So now, what can we prove from the given that because we got to have, remember, it's got to be one of these. HL, side, angle, side, 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 angle, side, angle, or angle, angle, side. That's all we have. Well, we have one side right now. That's it. What else can you see in the picture that you can prove definitively are congruent? And this is where you need to pause probably and think about it. But I see vertical angles. So I'm going to name those angle ABD is congruent to angle. Now, is this a fold over or is this a rotation? That's what you got to ask yourself. I believe it would be a rotation, right? So those would rotate, not flip, because you got to get these segments to match up. And they wouldn't match up by flipping. So if I said ABD, that would be angle EBC. Why? Because vertical angles are congruent. It's the vertical angle theorem. Okay? So that gives me 2 angles. Or I should say 1 angle and 1 side, a pair. All right, so what else can we prove are congruent? How about, well, it wouldn't be those angles, would it? How about this angle C and this angle D? Can we prove those are congruent? I guess that would be 2 of them, 2 arcs, wouldn't it, to match the book? There we go. Would those 2 be equal? And why? Alternate interior angles are congruent. Lines are parallel. Therefore, the angles, the alternate interior angles are congruent. So angle C would be congruent to angle D. So I think we can go right to it then, can't we? We have angle, side, angle. So triangle ABD is congruent to triangle EBC by angle side angle. Now, here is the deal though. These are also congruent by alternate interior angles. So we could have used angle side A. We'd have to say angle A is congruent to angle E, and then we would use angle side, or angle side angle the other way. It really wouldn't matter. I guess it'd be angle side, wouldn't it? So either ones work. So there's more than one way oftentimes to do these proofs. But the logic has to follow. You have to say this before you can say this. You have to say this before you can say this. So everything has to fit logically in a logical pattern. Okay, the last one. Explain how you can use the given information to prove that the hang glider parts are congruent. Now here's a neat story. I grew up in a town out in north central Kansas near a lake, huge lake, the biggest lake in Kansas, Lake Wilson. And we had hang gliders out there all the time on the weekends. It was unreal. The sky would just be full of them sometimes, and it was always so scary. Now this one's motorized, but the ones we always saw were just people running off a cliff and just hang gliding and staying out of the water, which was unbelievable. It was really neat. There were a lot of bluffs, and it was really cool. I don't think I'd ever have the guts to do it, honestly. So here we have this crazy looking triangle thing, and we're supposed to see if we can prove the triangle's congruent. Well, we're going to line up our T-chart here, our T-proofs, statements, and reasons. Now remember, hypotenuse leg, side angle side, side side side, angle side angle, and angle angle side are the only things it can be. So the first thing we're going to do is write down the given and mark it. It says angle 1 is congruent to angle 2. Now that's on the outside. All right. Okay. What else does it say? Angle RTQ is congruent to angle RTS. So let's mark that. RTQ. Oh, I'm going to have to do a different color. RTQ and RTS. So those two are congruent. That's given. Now, this one's hard. Let's see. Well, first of all, it says QT congruent to ST. Whoa. Hold the phone, guys. Don't mess with that yet. Because we've been proving triangles congruent. I think that's what we got to do first. We have to prove that the triangles are congruent. And the reason we do that then is then we can say that all the parts are congruent. Because remember, we had corresponding parts of congruent figures were congruent. Well, this is corresponding parts of congruent triangles. So let's see here. If we look at this, let's try to prove the triangle's congruent. Well, I see a side that we know is the same in both. Do you see it? Yep. RT. RT is congruent to RT by the reflexive property. And you can just write that, in my opinion. Okay, what's the third step? Well, we got to have one more thing. We need another angle or another side. And I don't think we can do another side, but I think we can do another angle. And this is a mess, actually. This is going to be an ugly proof, okay? If 1 and 2 were inside that triangle, it'd sure make life a whole lot easier, but it doesn't. But we do know that the measure of angle 1 plus the measure of angle TQR would equal 180. Now look at it closely. Why would those two add up to 180? Angle 1 and TQR. Right, because they're a linear pair, right? Linear pairs are supplementary. Okay. Well, what about angle 2 then? Isn't angle 2 plus the measure of angle, let's see, we did TQR. Well, what about TSR? Wouldn't that also equal 180? Again, linear pairs are supplementary. Okay, so let's see. Wouldn't we then say that those two are equal to each other? The measure of angle 1 plus the measure of angle TQR would equal the measure of angle 2 plus the measure of angle TSR because they're both equal to 180. Let's see. One part, now bear with me here. One part, two parts, three parts. What property is that? Right, it's the transitive property. That's how we know of equality. That's how we know those are equal. But wait a minute. What do you know about angle 1 and angle 2? They're congruent. So wouldn't that mean then that we could subtract them out and we would have this? If we subtracted angle 1 and angle 2 because it's the same number? Yeah. So TQR, that's this one, is congruent to TSR, and that would be because of subtraction. So there's something you wouldn't think you'd see in a proof. Okay, I think I've got enough to say then that these triangles are congruent, aren't they? So triangle QRT, I picked QRT, so what would go with QRT? SRT? And what would be the reason? Angle, angle, side, AAS. Now, we did not get to this yet, did we? Well, let's see. If we could fold those two glider wings together, and we've proven that the triangles are congruent by angle, angle, side, then wouldn't QT and ST be the same length because the triangles are congruent? But instead of saying, hey, because the triangles are congruent, those two parts have to be congruent, we say corresponding parts of congruent triangles are congruent. Now you'll notice I capitalized CPCTC. You may have not noticed that you already did CPCTC in the very first section in 12.1 when we talked about, or 12.4 maybe it was, when we talked about corresponding parts, how everything corresponded. You actually had a test over it, a Unit 2 test over it the other day, and you did very well on it. So this is the same concept. Now I know this was a long video and a lot of information, so I would probably walk away and watch it again.